Reincarnation. It's the idea that after death, something of us continues, finding a new form and starting over. Across different cultures and philosophies, it's seen as part of a grand cycle: birth, death, rebirth, governed by unseen forces. But what if this concept isn't just about life? What if the universe itself follows a similar pattern? Instead of a single beginning, some scientists propose that the universe undergoes continuous cycles of expansion and collapse. This idea, known as the Big Bounce, challenges the traditional Big Bang model, suggesting that what we see today is just the latest version of a universe that has existed countless times before. If true, our universe wasn't the first and won't be the last. It's a bold idea, but it's not just speculation. There's real science behind it. Could the universe itself be reincarnating? And if so, what clues might it have left behind? Let's find out. If reincarnation applies to living beings, why not to the universe itself? After all, everything in existence follows cycles. Stars are born, burn bright, and collapse. Planets form, decay, and disappear. So, could the universe also be part of an endless loop, dying and being reborn over and over again? Instead of a single creation event, one and done, the cosmos might be following a much bigger pattern. This is where the Big Bounce comes in, a hypothesis suggesting that the universe didn't just begin with a sudden explosion, like the Big Bang describes, but rather emerged from the collapse of a previous universe. Instead of one dramatic start, the universe could be expanding and contracting in an eternal cycle, reborn each time it reaches its end. If true, that means this isn't the first time the universe has existed. Maybe there have been countless universes before ours, stretching back into infinity. And if the cycle continues, there could be countless more after us. It's a strange but mind-blowing idea. The universe itself could be living through reincarnation, just like many believe humans do. But is there any evidence for this? And if so, how does it all work? For decades, the Big Bang has been the dominant theory explaining the universe's origin. It tells us that everything, space, time, matter, and energy, came into existence about 13.8 billion years ago from an infinitely small, dense point. Before that, nothing. No space, no time, no before. The universe simply began, expanding rapidly and giving birth to everything we see today. Simple, right? Well, not quite. Before our universe expanded, it may have been the end result of a previous one collapsing in on itself. Once everything condensed into a superdense state, instead of staying there forever or vanishing into nothingness, it bounced back into expansion, starting a new universe all over again. The key difference? The Big Bang model implies a one-time creation, while the Big Bounce suggests an eternal, cyclical universe with no real beginning or end. Some versions of the Big Bounce suggest that this cycle has happened infinitely, meaning there were countless universes before ours and will be countless more in the future. Others propose that this cycle might only occur once, meaning our universe had an infinite past before eventually expanding permanently. Either way, the idea challenges the traditional view that the universe started from nothing. One reason the Big Bounce remains an active area of research is that it avoids the problem of singularities, points where physics breaks down. In the standard Big Bang model, everything in the universe originates from an infinitely dense point, which general relativity struggles to describe. But in Big Bounce models, quantum physics might prevent the universe from ever collapsing into a true singularity. Instead, quantum effects could create a repulsive force at extremely high densities, allowing the universe to contract only so far before bouncing outward again. While this sounds promising, proving the Big Bounce is another story. Unlike the Big Bang, which has strong observational support, evidence for a previous collapsing universe is still largely theoretical. However, some researchers believe that traces of a past cycle could be hidden in the cosmic microwave background, the afterglow of the early universe. The Big Bang theory explains a lot about the universe, but it also comes with a few serious problems, one of the biggest being the horizon problem. This issue arises when we look at the large-scale structure of the universe and notice something strange. No matter which direction we observe, the universe looks remarkably uniform. The temperature of the cosmic microwave background radiation, essentially the afterglow of the Big Bang, is nearly the same everywhere, even in regions that are billions of light years apart. But here's the catch. According to the Big Bang model, these distant regions have never had enough time to exchange energy or information because they're too far apart. Light or anything else couldn't have traveled between them, yet somehow, they still appear identical. It's like placing 2 cups of coffee on opposite ends of the universe, and somehow both cooling to the exact same temperature without ever having mixed. Physically, this shouldn't be possible. This mystery is a major challenge for the standard Big Bang model because it suggests that these regions must have been in contact in the past. But according to the theory, they weren't. Scientists needed an explanation, and that's where the concept of cosmic inflation came in. It was proposed as a solution to the horizon problem, first proposed by Alan Guth in 1981. The idea is that, within a fraction of a second after the Big Bang, specifically from around 10 to the minus 36 seconds to 10 to the minus 32 seconds, the universe underwent an unimaginably rapid expansion. During this brief period, the universe's size increased by a factor of at least 10 to the power of 26, stretching space at speeds far greater than the speed of light. This sudden, exponential growth explains why distant regions of the universe appear so uniform. Before inflation, the universe would have been small enough for all regions to exchange energy and reach a balanced state. Then, as inflation rapidly expanded everything outward, that uniformity was preserved on a much larger scale. In essence, inflation solved the horizon problem by making the universe much bigger, much faster than a simple Big Bang expansion could. But inflation wasn't just a convenient fix, it also explained why the universe is so incredibly flat. Observations show that, on cosmic scales, the universe has almost no curvature, which is something inflation naturally accounts for by stretching space so much that any initial curvature gets smoothed out. Despite its ability to explain the horizon problem, cosmic inflation has faced serious criticism over the years. One of the biggest issues is that inflation isn't based on direct observational evidence. It's a theoretical patch added to make the Big Bang model work. The parameters that define inflation can be adjusted freely to fit observations, which raises concerns that it's more of a mathematical convenience than a fundamental truth. Another major problem is eternal inflation. Some versions suggest that inflation never fully stopped, but instead continues indefinitely in different regions of space. This would create an infinite number of bubble universes, each with its own physical laws, forming a vast multiverse. While this idea sounds exciting, it's nearly impossible to test or verify. If every possible outcome exists somewhere in the multiverse, then nothing in our universe is special. It's just a random result of infinite possibilities. These issues have led some scientists to explore alternative models, and this is where Big Bounce starts gaining traction. Instead of relying on an ultra-fast expansion phase, the Big Bounce naturally explains the universe's smoothness by assuming that before the Big Bang, everything was already in a balanced, homogeneous state due to a previous contraction. In this view, rather than a one-time inflation event, the universe has had enough time in previous cycles to reach the equilibrium we see today. One of the biggest problems with the Big Bang theory is that physics completely breaks down at the moment of the singularity. General relativity, which describes gravity and large-scale cosmic structures, fails to explain what happens when all the universe's matter and energy are squeezed into an infinitely small point. While the Big Bounce offers a compelling alternative to the Big Bang, it comes with its own set of challenges. One of the biggest problems is what happens at the moment between contraction and expansion. In order for a bounce to occur, the universe must avoid collapsing into a singularity, a point of infinite density, like the center of a black hole. But without a clear mechanism to stop this collapse, many physicists worry that instead of bouncing, the universe could just collapse into a supermassive black hole, never expanding again. Another issue is whether the universe will ever actually contract. Current observations show that the universe's expansion is accelerating due to dark energy, a mysterious force that pushes galaxies apart. If this acceleration continues indefinitely, the universe will never stop expanding, meaning it will never reverse into a contraction phase. This would eliminate the possibility of a future Big Crunch, which is essential for the Big Bounce to work. Even if contraction were possible, another challenge is determining whether information from a previous universe could survive into the next cycle. If each bounce completely resets the universe, then no physical evidence of past cycles would remain, making it nearly impossible to prove. Some scientists suggest that subtle imprints in the cosmic microwave background might hold clues, but so far, no definitive signs have been found. Despite these challenges, the Big Bounce remains an active area of research. Whether through Big Bang or Big Bounce, the universe's origin remains one of the greatest mysteries in science. The Big Bang tells us our universe had a single, definitive beginning, while the Big Bounce suggests it may be just one phase in an infinite cycle of expansion and contraction. If the Big Bounce is correct, then the universe itself experiences a kind of reincarnation, dying and being reborn endlessly, with no true beginning or end. While we don't yet have definitive proof, theories from quantum mechanics and cosmology continue to explore the possibility of past universes. If evidence of a previous cycle is ever discovered, it would fundamentally change our understanding of existence. So what do you think? Is our universe a one-time event, or are we living in just one version of a cosmic cycle? Let us know, because in an infinite universe, the possibilities are endless.